In this video, we're looking at relating ratios to fractions. We've got quite a lot of text on this page, so I'm going to ask you to pause the video and have a quick read. You don't need to actually answer the questions. I just want you to read all of the information and read these questions for now. Hopefully, you've had a chance to read the questions. So, students can either pass or fail the exam, and if they pass, they either get a merit or a distinction. And then we have this information here. Now, I'm going to represent this information using a bar model. Let's start with the first bullet point. The proportion of distinctions awarded is the same as the proportion that fail the exam. I'm going to represent this as follows. I've got a proportion of students being awarded distinctions, and I'm going to draw that as one box. And I'll label it D for distinctions. Now, I'm going to have the same proportion failing the exam. So I'm going to draw the same size box to represent that the same proportion of people are failing the exam as getting distinctions. Next, the bullet point tells us that 3 times more merits are awarded than distinctions. So if we have one box of distinctions, what we really need are 3 boxes of merits. So 1, 2, 3. And I'm labeling them M for merit. Now, I've just drawn this by hand, but the point is these are meant to be 5 equally sized boxes. And this diagram is now going to help us answer the questions we had. Let's start with A. What is the ratio of distinctions to merits achieved? Well, we can see from the diagram, for every one of these distinction boxes, we've got 3 boxes for merits. So distinctions to merits is 1 to 3. Let's have a look at B. What is the ratio of distinctions to merits to fails achieved? Again, we can use the diagram. Now we need to be careful because the order I've drawn the diagram in doesn't match the question. We need distinctions, then merits, then fails. Well, for every 1 box of distinctions, I've got 3 boxes of merits and 1 box of fails. So that's 1 to 3 to 1. In question C, we're looking at what fraction of students sitting the exam achieve a distinction. Now remember, the whole point of these boxes was to represent equal numbers of people. So what we can see here is that 1 out of 5 equal parts are getting a distinction. So that means 1/5 of the students are getting a distinction. Next, let's have a look at question D. Of those that pass, what fraction achieve a distinction? Now, this is not the same question as the one before. Before, we wanted to know what fraction of all the students achieved a distinction. In question D, we're only interested in the ones that pass. So let's just focus on the relevant part of this diagram. What I've got here is the same diagram as I had before, but without the failures. So I'm only looking at the people that passed. And out of the ones that passed, what fraction got a distinction? Well, I've now got 4 equal parts, and only one of those parts represents people who got distinctions. So the fraction of those that passed that achieved a distinction is 1/4. Just to be clear, I'm going to label this diagram on the right-hand side my diagram for part D, and this diagram here was for A, B, C, and we're also going to see that we'll use it for part E. Given that 239 people achieved a distinction, how many people sat the exam altogether? Well, 239 people achieved a distinction, so I can label that on the diagram like this. Now remember, each box is supposed to represent an equal number of people. So if this is 239, then the total number of people who sat the exam is 5 lots of 239. And if you work that out, you'll see that 5 multiplied by 239 is 1,195. So 1,195 people sat this exam all together.